Smart Shower is a project developed under the scope of the IoT class of Politecnico di Torino, developed by Valerio, Galeone Andrea, Marangi Antonio e Smerilli Lorenzo. This is an IoT implementation aimed at saving resources such as water or fuel, save money, and analyze the trend in shower consumption under a domestic environment. It is a software and hardware integrated solution, microservices based, that exploits different communication protocols. Prototype hardware includes different simple components used for a test demonstration. Basically, each actor forming the solution has a particular functionality, and it is totally decoupled from all the others. Let's see an overview of their schematics. Telegram bot, which is the main user interface. Shower catalog, whose aim is to set up the network. Sensor interface, which is formed by a Raspberry Pi and an Arduino, working to connect the sensors to the network. Resource control is the microservice in charge of sensing consumptions. Comfort controls provide control for user awareness. ThinkSpeak and Freeboard adapter works to convert and send data to cloud services and Freeboard. Altogether, they form the Smart Shower project. Let's see each of them in detail.
The Telegram bot is the main interface between the user and the Smart Shower. It communicates with the catalog, with the resource control and the comfort control, and it gives accessibility to the freeboard. It gives to the consumer the possibility to create a new user and to add a new shower, and automatically creates the new family if it wasn't present. After the creation, the user can start a shower among those in his family. The user must add some personal data, such as the desired temperature, the gender, his personal email, and, if it is the first registration for his family, also the IP of his hardware. Then he can add the new shower, and once done, he can start taking a shower. The list of the showers is taken from the catalog through REST communication, and when the user clicks on a shower, the Telegram bot sends a GET request both to the resource control and to the comfort control to advise them that someone is going to have a shower. After the person has finished taking a shower, he receives the amount of water consumption, methane consumption, and cost of his last shower. He receives also the link to see a graphical representation of his consumption, but also of the consumption of the rest of his family. The bot is useful also to advise users when there is a problem with one of them showers. In fact, when the catalog releases a shower, sends a GET request to the bot that connects all the people in the same family of the shower.
Now we will talk about the shower catalog. The shower catalog is a piece of software with the purpose of keeping a registry of the available devices and users present in the Smart Shower application. It communicates directly with the Telegram bot, from which it receives all the information about the families, with the device connector to keep a track of the sensors, with the control strategy and the ThinkSpeak Freeboard adapter to exchange informations. These informations are all stored in a JSON file, to which only the catalog has access. As we can see, in the beginning the catalog is empty, and only after a put request coming from the Telegram bot, it will be filled. We can notice that between the put requests there is a GET request. The GET request is done so every users and showers in the same family are unique. One of the most important information contained in the catalog is the IP address of the broker that is fundamental for the functioning of the entire application. Almost every microservices need this information. It can be seen in the catalog in the JSON file that the broker is called. When creating a shower or a user, the shower catalog creates the feed's name that are then sent to the ThinkSpeak freeboard adapter to draw the consumption graph. At the end of the shower, the ThinkSpeak adapter will request the catalog for the name of the fields, as can be seen from the video. The sensors do a GET request to the catalog after a certain time, such that if a device is not communicating, it will be removed from the catalog and the user will be informed. From the video we can see that after 1 minute, because we set this time in this case, just to let you see the fact that the shower has been effectively deleted, we can see that the shower not working has been deleted after a certain time. Basically, apart from the request from the bot, the main request happening in the catalog is a GET request, such that the other services can obtain information from the catalog. To render possible the check of the device functioning and at the same time the processing of a request, the shower catalog is implemented through the use of multi-threading. Even if there is more than one request pending, all the functions are almost immediate, so there is no need to multi-thread the rest part. So, as we can see from this part of video, the shower catalog works exactly in the same way of if there are more than one shower and one.
The sensor interface is the link between sensor and both resource control, comfort control, and shower catalog. It requests to the catalog the IP of the broker and sends to the catalog a GET request to advise it that the sensor is still working and so to refresh the timestamp.
The flux sensors takes the analog input and transform it into digital output. The data that are taken from the sensor are sent via MQTT to the resource and comfort catalog, with an extra data that inform that the shower is finished.
The temperature sensor reads every 5 seconds the temperature and sends it both to the control control and the resource control.
Thanks to a C program that runs in Arduino, the flux sensor takes the liter per second digital data, then they are elaborated with a Python program in order to send via MQTT to the resource control.
The sensor interface uses light and sound stimuli. In fact, a green LED is turned on and the music starts playing when the comfort control reports that the water has reached the desired temperature, while a red LED turns on when the resource control indicates that the shower is taking too long.
Resource control is the core of the controlling systems. It is in charge of sensing the temperature and flow information coming from the sensors, provides alerts in real time, manipulates and sends data to the middleware. It communicates via MQTT with the middleware adapter and with the sensor interfaces, while it exploits REST to receive await commands from the bot and check data consistency with the catalog. At the same time, uses two different communication protocols, informs ThinkSpeak of consumptions, and provides alerts in real time to the user in case limits of usage are reached. Multithreading is adopted to deal with multiple showers at the same time. When GET request arrives, Resource Controller sets up the MQTT clients and starts sensing flux and temperature coming from shower sensors. When usage limit is reached, it sends a true command to light up the red LED. When the shower finishes, it processes and packs data to be sent over MQTT to ThinkSpeak adapter. Comfort Control is the microservice in charge of sensing the readiness state of the shower. It communicates over MQTT with sensor and via REST with Telegram bot and catalog. Similarly to the resource control, it is awaked by the bot and sends command to speakers and LED to inform users. Multithreading again is adopted, but this time to protect the speakers as exclusive shared resource. When the comfort control receives the GET request from the Telegram bot, it starts sensing the temperature coming from the sensor, from the shower. When the temperature preferred by the user is reached, it sends the true command to light up the green LED and start the music. When the shower is finished, a false command will be sent to stop music and light off LED.
FinSpeak adapter is the link between the resource control and FinSpeak. Instead, Freeboard adapter connects the FinSpeak platform to the Freeboard. That division is only a conceptual division in order to explain how it works, because in reality they are a series of microservices that work together. On the graph we can see the different kind of connection. In particular, our adapter talks to the resource control with MQTT, and FinSpeak, Freeboard and the shower catalog are connected with REST. Now let's analyze the first adapter. The purpose of this adapter is to take the information of a single user's shower from the resource control via MQTT. It understands if it is a new or a old user of shower. To do that, it sends a GET request to the shower catalog. It sends the data to FinSpeak in order to store it. Then the data are taken from FinSpeak and processed by the code in order to have mensual and annual consumption. MQTT and REST work synchronously thanks to the multithreading. Freeboard adapter takes the data that FinSpeak adapter has processed, and it creates the JSON files that Freeboard uses to make widgets and graphics. When the users use a shower for a complete year, the Freeboard adapter sends a GET request to give the annual price in order to show the trend of the charge. Every time that a user sends a GET request to see the Freeboard, an index file will be created.